Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 4th, 2025, about 4 days ago. The standout here is a new framework that pinpoints memorization at the level of individual tokens in chain of thought reasoning and shows local memorization can drive up to 67% of wrong tokens. The paper is titled, Diagnosing Memorization in Chain of Thought Reasoning, One Token at a Time. And as we'll see later, the implications for model training are quite significant. In short, the method attributes each token to local, mid-range, or long-range sources and predicts which tokens trigger cascading errors. Building on that, the tweet echoes the core message. A single wrong token can derail reasoning, and token-level memorization, especially under distribution shift, is a key failure mode. It introduces STIM. Engagement looks solid, around 100 likes. Alright, this figure shows how one wrong token sparks a chain reaction. The input story is fixed, then the model steps start fine, but the token 3 in today Rick killed 3 times as many gets misused, producing 9 wolves. Building on that, each later sum or difference compounds the mistake, ending with 46. Next, this table walks through 2 concrete cases. The counting example flags the token 5, where a locally frequent pattern, appearing 5, dominates with a high local score. Then, the binary math example highlights token 180, where input co-occurrences dominate, yielding a higher long-range score. Together, they illustrate source attribution. Building on that, this graphic walks through one faulty step. The highlighted question sets context. Then the orange block shows the reasoning where the token 3 triggers 9 wolves. Below, 3 panels score local, mid-range, and long-range influences, and the maximum score flags local memorization as dominant. Moving to the results, 3 box plot panels compare STIM max scores. Left, harder tasks like applied math and formula calculation sit higher than counting and capitalization. Middle, long tail inputs shift scores upward across tasks. Right, under long tail, wrong steps surpass correct ones, indicating memorized fallbacks now drive errors. Next, this table quantifies which source dominates errors. Local memorization tops most rows, reaching 67% in counting long tail and around 65% in capitalization. But under long tail for applied math and formula calculation, local drops while mid and long inch up, signaling a shift toward broader context influences. Building on that, 2 takeaways. First, STIM pinpoints which token and which source, local, mid-range, or long-range, likely caused the failure, with local memorization dominating many errors. Second, memorization spikes on long-tail inputs, flipping correct to incorrect. That is, the AI research